Have you ever heard of a way to turn something as simple as a safety pin into a homemade welding machine? It sounds strange, maybe even a little unbelievable, but trust me, it can be done. And in this video, I'll show you exactly how I made it happen. Next, I have a bolt and a nut, sized just right to secure firmly onto the safety pin. I'm using the safety pin as a connecting piece between the welding tip and the handle. And this bolt here is part of the welding head. But don't get it wrong, the bolt itself is not the welding tip. Once the bolt is firmly secured, the next step is wiring. You want to use a single core electrical wire, and if you have a red one, even better. Not for any special reason. It just makes things easier to identify, since this wire will be connected to the positive terminal of the power source. Here, I have a plastic tube that's just the right size. Once installed, it makes the handle feel more solid and gives a much more comfortable grip while welding. Now, to secure the safety pin firmly onto the plastic tube without making things complicated, I'm going to use a small trick with toilet paper, liquid glue, and baking soda. It sounds simple, but the result might surprise you. Let me show you how I combine these three to lock the safety pin tightly onto the tube. And just like that, the safety pin is now firmly secured inside the handle. Pretty simple process, right? To connect the welding head to the welding tip, a connector block is absolutely essential. Here, I'm going to take out a metal piece from this electrical terminal block and use it as the linking component. Do you believe that the core inside this AA battery can actually be used as a welding tip for a homemade welder? It sounds hard to believe, maybe even a little risky, but once you look more close at how it's made, the idea starts to make a bit more sense. This core is designed to conduct electricity efficiently, and under the right conditions, it can tolerate a certain amount of heat without immediately deforming. That's why, in the DIY world, some people have experimented with using it as a temporary alternative. What makes the battery core interesting is its shape. It's compact, straight, and rigid enough to help focus heat into a small, control point instead of spreading it everywhere. Because of that, generating heat for simple welding tasks becomes more achievable than with many random materials. Of course, this is not a purpose-built welding tip, and it was never meant to handle this kind of work over the long term. But in the spirit of DIY, the goal isn't always perfection. Sometimes it's about finding creative ways to turn overlooked objects into something useful. The AA battery core is a good example of that. Not as a replacement for professional equipment, but as proof that understanding the materials you have can unlock some surprisingly interesting possibilities. Once you sharpen one end of the battery core, it already starts to look very much like a real welding tip. When installing the welding tip into its proper position, make sure to take it easy. If you apply too much force while tightening the screw, the battery core can easily crack or break apart. As for the other end of the wire, I'll attach an alligator clip to make it easier and more convenient to connect to the positive terminal of the power source. Of course, we can't forget to make an additional tool to connect to the negative terminal of the power source. This part has a fairly simple structure, consisting of a single core electrical wire, but it plays a crucial role in the overall setup. Both ends of the wire are fitted with alligator clips, making it easy to attach one side to the negative terminal of the power supply and the other to the workpiece. Since I forgot to charge the battery, I'll use this cordless drill battery as a power source instead. I'll use these two metal rings as intermediate connectors to link the power source to the homemade welding device in a stable and practical way. Don't worry, the battery core is just a bit damp and will work fine once it dries out. I'm only running some simple tests here, because realistically, that's about all a homemade mini welder can handle. But don't judge it too quickly. Stick around until the end, and let's see how well it actually performs. This part can be considered a little bonus for everyone. I'm going to try fixing a damaged LED bulb, which stopped working because one of the LED chips inside has failed. I'll be using the same homemade mini welder to handle the repair. But before anything else, we need to open the casing, because only by looking inside can we figure out exactly which LED chip is causing the problem. Using tweezers with an insulated handle is safer electrically, especially when checking components that may still have power. There it is, we found the problem. Now let me show you how easily I take care of it. In fact, that spot only needs to be filled with a conductive material, so I'll use a simple soldering technique. Soldering a piece of solder directly onto the failed LED chip to restore the circuit. The light bulb has been successfully repaired, so this is where I'll wrap up the video. From building a simple homemade mini welder to fixing an LED bulb that seemed completely beyond repair, this entire process shows that broken doesn't always mean useless. With a basic understanding of how things work, a bit of patience, and a willingness to experiment, many everyday problems can actually be handled on our own. Of course, this homemade welder can't replace professional equipment, and it comes with very clear limitations. But the real value lies in the DIY mindset behind it. Making use of what you already have, understanding your tools, and knowing when to stop to stay safe. I hope this video doesn't just show you an interesting technique, but also encourages you to look at broken items from a different perspective. Maybe next time something stops working, instead of throwing it away, you'll feel curious enough to open it up, take a closer look, and try fixing it yourself.